All right, how's it going? Now, yesterday we used synthetic division to factor and solve. So I gave you a polynomial or a function, and then I would give you a value for k, whether that be expressed in x or function form or whatever it may be. Today, looking at this first example, I could give you x to the third minus x squared minus 21x plus 45. Now, that's all I'm going to give you, and I'm going to ask you to factor this and find the zeros. All right, now, notice looking at it right now, we usually had a number here to start with. I would say f of some number equals 0, or k equals some number, or x equals some number, and we would use the factor and solve. Well, today, what we need to do is use our calculator to find a 0. Okay, so use the calculator to find the 0. All right, so we at least need to find 1 to start. So take out your trusty calculator, go to your y equals menu, and we're going to type in x raised to the third minus x squared minus 21x plus 45. And I'm going to put y equals 0 here for when we have to find the intersection. All right, now that's what my graph looks like there. So from the looks of it, we got two zeros, one around here and one around here. So second trace to our calculate menu, we want to find the intersection. All right, right now, where am I at? I'm at negative almost 1. Heading down here. Where are you at, Spidey? Oh, went too far. Alright, so we're heading back up. And there he is. Alright, so I'm going to hit enter. It jumps to the other curve. Enter, enter. And it gives me x equals negative 5. So x equals negative 5. Now, you could continue going through and find this other 0 if you want. But let's use synthetic division now that we have a starting point. So I know my factor in the end that I'm going to have to bring back is x plus 5. So I have negative 5, draw my upside down house, coefficients of 1, negative 21, 45. Bring down the 1. Negative 5 times 1 is negative 5. Add them up, negative 6. Go through your process. 30, I get 9. Negative 5 and 9 give me negative 45. And bam, I get 0. So I have x squared minus 6x plus 9. So do I have two numbers that multiply to negative 9? Multiply to positive 9 and add to negative 6. That gives me x minus 3, x minus 3, and don't forget your x plus 5 factor. All right, now, so if I wanted it factored, that's where we go from there. If I wanted my zeros, I have x equals 3, and x equals negative 5. Now notice we got two x equals 3's. Now if you look at your graph, all right, if we take a gander at our graph, notice that's where it bounces. All right, and we discussed that. Okay. So my graph comes up here at negative 5. It hit there, and at positive 3 it hit there. So it came up pretty steep. It came and it bounced right at this point here. Alright, so that's what my function looks like. So the only new piece we're really adding here is finding the 1, 0, finding the starting point with the calculator. Alright, let's try another one. Now the next one's going to be a little more difficult, and we'll do more like this in class tomorrow. Let's go x to the 4th plus 7x to the 3rd minus 7x squared minus 63x minus 18. So that's all I'm giving you. All right, so let's go to our calculator, go to the y equals menu, and type in this one. So clear out what's there. X raised to the 4th power plus 7x raised to the 3rd. Didn't get my caret key there. Minus 7x squared minus 63x minus 18. All right, graph. Woo! A lot of stuff happening there. Now, let's find a starting point. So second trace intersect at y is negative 18. So I'm going to come up here. There he is. I'll move all the way to the left. Now let's see if this is a nice number. Enter, 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 and I get negative 3. X is negative 3. That's a good one. So x is negative 3. Now, let's start there and just get moving then. So I'm going to put negative 3. Whoa. Draw my little upside down house. 1, 7, negative 7, negative 63, negative 18. So bring down your 1, multiply, negative 3, sorry. Add gives me 4, multiply, add gives me negative 19, multiply, 57, add, multiply, and look at that. Worked out perfect. So don't forget, x plus 3 is going to be one factor. So now let's rewrite this. X squared, x to the third, because I'm 1 degree less than up here, plus 4x squared minus 19x minus 6. Now notice we really can't do much with that. Alright, so what we need to do is find another 0 and use synthetic division again. So we had one factor. So I'm going to highlight this so we don't forget about it. Then we're going to go back to the calculator and we're going to calculate another intersect. Now, some students like to do all of them right at the beginning. Alright, so they like to go through, find all 4 intersection points at the beginning. So in the event this happens, we have a pointer ready to revisit. But, so, I'm going to go to the right here. This one doesn't look nice, and this one looks, I don't know. So I'm going to try to get this one far to the right here, because that looks like a nice number. Okay, and we'll do some calculator work in class tomorrow and talk about maybe some easier ways to find these things. Okay, so we enter, 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 and that one gives me positive 3. So that's a nice one. Now, if you go to the table, sometimes, too, you can identify them pretty quickly. Look at that. 0, negative 3, 0, 3. So we would have had 2 already, because on y0, those are my intercepts. So that's another option you have. You can go second table, or you can calculate the intersects on the graph. Either way, x equals 3 is the next one I'm dealing with. So x minus 3 is my factor. Again, I'm keeping track of these factors because in the end I'm going to have to put them back in. So now what we're going to do is we're going to use synthetic division again with this number, so with 3 and 1, 4, negative 19, negative 6. So let's see where this gets us. All right, so bring down my 1, 3, 7, 21, 2, 6, and that worked out nice again. So I have x squared plus 7x plus 2. Then don't forget about x minus 3, and up here I had x plus 3. Alright, so now if I asked you to factor, we would stop here. Alright, we're in factored form, but if I asked for all of the zeros, so you find all the zeros, alright, we have 1, we know this is x equals 3, and this is negative 3. So actually we have 2 zeros. Okay, we knew those already. Now, how would I find the zeros for this? Well, if you can't factor it, we have to resolve to the quadratic formula. So x equals opposite b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So negative 7 plus or minus square root 49 minus 8 all over 2 gives me negative 7 plus or minus square root of 41 over 2. So there's my other 2 solutions. So Your solutions in all, x equals 3, x equals negative 3, and x equals negative 7 plus or minus root 41 over 2. Again, many of you are probably telling yourselves, well, I can just go find them all in the calculator. Yes, except for when we get, you guessed it, imaginary solutions. Because if we had an imaginary solution here, you would still have to go through the process. And by using synthetic division, sometimes you might have to do it 2 or 3 times, but eventually we'll reach the answer we want. So again, what prompted me to go back and divide more was the fact that when we got here, we didn't have a solution, right? We can tell we had a cubic function still, and we can factor further. So again, some people like to find all the zeros, list them out. If you got all 4, you can answer the question. But if I asked for factored form, you'd have to go here. All right, sorry, that was a mouthful. I was rambling for a while. Hope I didn't confuse you. We'll touch on this in the morning tomorrow, and we'll review everything here. All right, have a good night.